Hi students, we are going to talk about domain and range today. So topic 6, domain and range. Ultimately, all functions do is just convert inputs into outputs. Okay, so that's what a function is for, is to convert inputs into outputs. So the domain of a function is a collection of all of the inputs. So essentially asking yourself that question here of what are all of the inputs, and that's the answer to the domain. And then the range of the function is a collection of all outputs. So the range is the outputs. And again, ask yourself, what are all of the outputs? And just make a list of all of the outputs. Sometimes it's a list, sometimes it's an interval. So that's what you're going to do from there. So for a discrete function, for a discrete function, when a function has a countable number, so you can actually count how many inputs and outputs, there's not an infinite number of them, the domain and range can be listed in roster notation. So we can list them. So I'm going to give some examples here of doing that. So in this first example here with this function, and I'm going to just put a D when I'm listing my domain and an R when I'm listing my range, but we can list in roster notation is going to have these little curly brackets on them. How you make those brackets isn't like, it doesn't have to be perfect, but they're going to be like that. They're not parentheses. Okay, so in a domain, we're going to make our little bracket, and the inputs for this, you can see the arrows going here, are all of these guys here. So these are my inputs. And so a domain is just a list of all the inputs. So I'm going to list them. So I'm just going to do 1, 2, 3, 4. Now you cannot just write from 1 to 4 because that would include something like 1.2. And we don't want to include that. So you have to list them with comma separated. Then the range is just the list of all of the outputs. So if I look at this, all of the arrows go over here. And so this is a list of my outputs. And so if I want to know the range of this function, it's that list. Now it doesn't matter if you put them in order, but I like to. So I'm going to do 2, 3, 4, 5 instead of putting them in the order that you see there. So we're making a list for our domain and range. So if we do that again, we've got another function right here where I'm going to be able to list these. So again, these are my inputs and these are my outputs, and all I'm doing is listing my domain and range. So my domain is all of the inputs. So if I make a list of them, all of the inputs are right here. So 0, 1, 3, 4. Those are all of my inputs, and then close that little bracket there. And then my range is all of my outputs. Now in this one, 1 and 3 both go to the output of 1, which again really still means that this is a function. I'm not going to list 1 more than once. I'm just going to list the outputs that are there once. So I have an output of 1, I have an output of 2, and then I have an output of 3. So it is okay if your domain and range have a different number of numbers in them, okay? Then we get into this list over here, which is a table. It's the same idea. My inputs are my x values here. My outputs are my function values, which remember a function value is the same as a y value. So we have those outputs over there that are those function values that we can utilize. And so I can go through and I can list those. So my domain for this function is going to be a lot longer than the other one. And again, if you want to list them in order, these ones are in order, so that's pretty easy. So -4, -2, 0, and then 3, 6, 7, and 8. Again, notice I put a comma in between each one of those. That's how we should separate our list. And then our range in this case is going to be all of these outputs. Now you can put these in order or you can't. I'm going to go ahead and do that. So -10 would be the smallest, then -5, then -4, and then, oh, no, we don't have a 0 in this one. I was thinking there was a 0. And then let's see, we have 4, 5, 7, and 9, and none of them repeated, so I just making sure that I don't repeat any of them, but they're all listed there. So that's my domain and range. Now when you get to a graph, this is when a lot of people struggle with this, but in this graph here we've got 4 points that are shown. Our domain, remember, is our input. So our domain is going to be a list of our inputs, which on a graph are our x values. Okay, so remembering that. So if I go through and I look at like the x value of this point here, okay, is going to be what's down here, which is 1. This point is going to be down here, which is at 2. We don't have a point at 3. We do have a point here at 4, and we do have a point here at 5. So that's going to be my domain. So I'm going to list my domain here as 1, 2, 4, and 5. Again, it's not a continuous domain. It's discrete, so you're going to list those numbers. And then the range in this case is going to be the list of the outputs. And so if I make my way up, there's not one at 0. And maybe it depends on how you kind of look at this, but I can come over from here and see that there's one at 4. This point is right here at 5. This point down here is over here at 1. And then this point over here, we're at 3. So if I list all of those outputs right there for my range, I make my little bracket, I would list 1, comma 3, comma 4, comma 5. And so there's my domain and range in roster notation, which is one of the available notations, and that's what you use when you have a discrete function. So if you have a continuous function, when a function is continuous, which means we're going to have decimals, we're going to have all kinds of stuff in between there. You can look at them as fractions, whatever. The domain and range must be represented with an inequality or an interval. So we've done a lot of work with inequalities and intervals. I'm going to write them as both in this, but you can write them as one or the other. So domain and range here. So if I'm looking at this function right here, remember domain is all of the input. So it's all of the x values. So I'm going to go ahead and do an inequality notation first. So every time you start an inequality for domain, it starts like this. And the left side is the left side of the function. So the left side of the function, x values. So the reason I did that is because it's x values. The x value of this is at -1. And then the x value of the right side is at 5. So the x values are from -1 to 5. Now, we also talk about whether they're included or not, and that is included. It's not an open circle, so I'm going to make an equal sign, and the same thing with the right side, so I'm going to make an equal sign. If I were to write that in interval notation, it would be with a bracket, and it would be from -1 to 5 with that comma in between, so that comma means something different than the commas up here, because this is written in interval notation. Why? That's also why we use different brackets in each one of those. Then the range for this function is going to be based on the y values that are happening. So we do kind of the same thing. It doesn't want to let me change color, so I guess I'm not going to use a different color. Oh, there it goes. Okay, so the range for this function is the y value. So if I come over and I find the y values of this one's at -5, and this one up here is at 7. Now you have to be careful. A range is y values. So when I start this off, I do it with a y with the less than symbols. So what is less than the y, or the least one, is way down here at -5. And then the greatest one is the one that's at 7. And because, again, those are filled in circles, they're not open circles, we're going to make those equal to. Writing that in interval notation would be from a closed bracket of -5, comma, to 7, and another closed bracket there. So that's how we would write that. Again, one of the big things that you're seeing there that's different is that y value in there, and it's in there when you talk about range only. Okay. If we come over here to this one, my domain, let's say I write this as interval notation first. Well, an interesting thing happens here. Let's just look at it. So we have our graph here, but if you notice, there's an open circle there, which means that at -5 there's an open circle, but then there is a point at -5 up here. So we're going to talk about that as we go through this. So the domain is all of the x values. So if I were to cover the entire x-axis is at this point, do I have a value? Yes, I do. At this point, yes, I do, and so on and so forth. So the question is, at this point of -5 and an x value of -5, do I have a point? I do. It just happens to be up here and not on that line. But if I keep going at every value, including 8, there's a value. It's way down here below the graph, but at every point we have a value. So the domain in interval notation would be from -infinity to infinity. And remember, you never include infinity because you can't actually get there. And then in inequality notation, I would write it as -infinity is less than x, which is less than infinity. So one of those for your domain. Then your range for this function, your range for this function is going to be the y values that we hit. And this one's a little interesting. So if I come down and I say, okay, at -10, do I have a value? I do. And we can keep going across here and finding values and saying, yes, we have values at all of these levels. The interesting one is the dot. Okay. Is there a value of this function at 0? And because there's a dot there and there's no other dot along here, there is not a value of this function at 0. So the range for this function is going to go from, remember, we go bottom to top for range, so -infinity, +infinity. We're going to go from -infinity, if I can draw infinity, comma, to 0. Remember, we stopped here and said there isn't something there, and we're not going to include that. And then we're going to start again at 0, but we're starting on the other side of 0. That's what this is doing here. And we're going to +infinity. Okay, it does keep going. There are values here, here, Even here, there's actually two values because there's one there and there's one where the function would be. And again, there's going to be values at every one of those levels. Okay, so that's the range. Writing that inequality is a little bit more cumbersome, but you would write negative infinity is less than y. Remember, it's y, which is less than 0. And then you would also write 0 is less than y, which is less than infinity. So over both of those intervals is the range there. Okay, thank you.